not, in which topic you need to do, that has to be done in the tripping time calculation. But before going to do the tripping time calculation, first of all we should know what are the different types of circuit breaker we have and what is the standard tripping time, saturation time and all. So now let us study about the circuit breaker sizing and circuit breaker topics. Now first of all, what is the purpose of circuit breakers, guys? The purpose of circuit breaker is nothing but to make a circuit or to break a circuit. Circuit breaker की जरूरत क्या है? The purpose of circuit breaker is nothing but to make a circuit or break a circuit. Make a circuit means to on the circuit breaker, to on the circuit. Break a circuit means to break the circuit, means if any problem occur it will get tripped. The purpose of circuit breaker is to make a circuit and break a circuit. Make a circuit means to switch on the circuit. Break a circuit means, what is break a circuit? If any problem occur it will automatically get tripped or off. Now it mainly helps in protecting the circuit under three conditions. Circuit breaker, what they'll do, they helps in protecting the circuit under three conditions. What are the three conditions? The first condition, what is the first condition? If the current drawn by the equipment is more than the rated full load current, it will get tripped. Circuit breaker protect the circuit under three conditions, guys. Circuit breaker protect the circuit under three conditions. Okay, circuit breaker, it mainly helps in protecting the circuit in three conditions. What are three conditions? If the current drawn by the equipment is more than rated, full load current, it will protects. If any fault occurs and the fault current increasing the beyond the set fault current, it will also protects. And it also helps in protecting the circuit under any leakage occurs. Circuit breaker mainly helps in protecting the circuit under three conditions. What are the three conditions? The first condition is if the current drawn by the equipment is more than the rated full load current. If the current drawn by the equipment is more than rated full load current, then it will get tripped. Second, if any fault occurs and the fault current increases beyond the set fault current, then it should get trip off. It also helps in protect the circuit under any leakage occurs. According to this, circuit breakers are classified into three categories. The first one is protective circuit breaker, second is HT set circuit breaker, third is LT set circuit breaker. Circuit breakers are classified into three categories: protective circuit breaker, HT set circuit breaker, and another is LT set circuit breakers. Okay, so now first of all let us see what is protective circuit breaker. Protective circuit breaker means which helps in protecting the circuit under any leakage occurs as well as an unbalanced condition occurs. And according to that, there are three types of circuit breaker. What are they? ELCB, RCCB, and there is RCBO. Okay, protective wise we have three types of circuit breaker. The first one is ELCB, earth leakage circuit breaker. If my leakage current which is more than 30 or 300 milliamps, agar mera leakage current, if my leakage current which is more than 30 or 300 milliamps, then my circuit breaker will get trip off. Leakage current का मतलब क्या है? What do you mean by leakage current, guys? If anywhere the cable insulation got cut, or inside the fan you have a winding, on the winding you have a varnish, on the fan winding you have a varnish. If the varnish has gone, so then at that time what happens? If the cable insulation got cut, the current starts leaking. If the current is leaking, then what happen, guys? If the current is leaking, then what happen? If the current is leaking, then what happen? The equipment total will become a current carrying conductor, and if you touch to that equipment, you will become a current carrying conductor. You will feel shocked, and there's a chance for the person to get die at certain situations also. So now what I need to do? I need to provide your total building in such leakage current. Okay, so if my leakage current, so what is the saying ELCB? If my leakage current which is more than 30 or 300 milliamps, then my circuit breaker will get trip off. And that leakage current, if it is more than 30 or 300 milliamps, the circuit breaker will get trip off. Why? Because human body will able to withstand up to 30 or 300 milliamps. Okay, then where do we use this ELCB then? It has to be used in the distribution board as an incomer. Do you remember distribution board? We had calculated outcomers, but the incomer I told you we might be using ROCB. Why? According to the unbalance of that between R to Y, Y to B, B to R, the load should be balanced. So that distribution board incomer, first it was started people using with ELCB, but now what is the drawback of ELCB? That drawback of ELCB is it gives only leakage current protection, but it does not give any unbalanced protection. Okay, so if my leakage current which is more than 30 or 300 milliamps, then the circuit breaker will get rip off. But in order for the circuit breaker to get rip off, that incomer which you are providing, we need to give RYB and earth, not neutral. Okay, because if any leakage current which is coming back to that circuit breaker and if that leakage current which is more than 30 or 300 milliamps, it will get rip off. So this is mostly used in distribution board as incomer, but in the present scenario we are not using. Why? Because this have a drawback that it does not give any unbalanced protection, it only give a leakage current protection, and short circuit current protection will also not be given. That is the reason ELCB is not preferred nowadays. But first invented was ELCB. Then advanced of that, people came with a concept called as an RCDs, residual current devices. In that residual current devices, we have two types of circuit breaker: RCCB, residual current circuit breaker, and residual circuit breaker overload, or RCBO. Okay, RCBO or ROCB, residual over circuit breaker. Now, in which the first one is RCCB, residual current circuit breaker. This type of circuit breaker is mostly used for three-phase motors. For three-phase motors, we specifically use this RCCB because it is, if any unbalance of currents take place between the phases, it will get trip off. It helps in protecting the circuit under leakage current, that is 30 or 100 or 300 milliamps, it will get trip off. If any unbalance of currents take place between R to Y or Y to B or B to R, it will get trip off. That is about the RCCB. Then advanced of this RCCB, people came with a concept called ROCB or RCBO, residual over circuit breaker or residual circuit breaker overload. Now RCBO, you know, it's a combination of MCB plus RCCB. It's a combination of MCB plus RCCB. It gives the protection under earth fault also, where you will get in the market 30 milliamps, 100 milliamps, 300 milliamps. Overload protection also you will get. Short circuit protection also you are going to get. Mostly used nowadays in the distribution board, this as an incomer. So maximum people nowadays, people are going with this kind of circuit breaker as an incomer, or we can go with RCCB also, but this is more superior because it gives all protection, but only thing is costly. Okay, it will be very much costly. Okay, so that is about the protective circuit breakers. Next is LT set circuit breakers. LT set circuit breakers. What are LT set circuit breakers? LT set circuit breakers are again classified into three category: MCB, MCCB, and ACB. First, let us go with MCB. MCB stands for miniature circuit breaker. Okay, miniature circuit breaker. It is available in SP, DP, TP, single pole, double pole, and triple pole. MCB is available in three category. SP. SP means only the single pole, where you are controlling phase, neutral is not controlled. Double pole. DP means two poles, where phase and neutrals are controlled. TP means triple pole, where R, Y, B will be there. TPN means R, Y, B neutral, where R phase, Y phase, B phase, and neutral also will be controlled. So, but MCB is available in SP, DP, TP, and up to how much ampere rating MCBs are to be used. If your current rating in the LT side, is from 0 ampere to 63 amps, then we only go with MCB. अगर आपका current rating in the low tension side 0 ampere से 63 amp तक रहेगा, then we go with MCB. And in that MCB, we have three types of MCB again: B type, C type, D type. B type is used for resistive loads, guys. Same, abhi suppose example in the market you will see 20 amps ka B type bhi milega, you get 20 amps B type also, you'll get 20 amps C type also, you'll get 20 amps D type also. But what is the difference? B type is mostly preferred for resistive loads. Resistive loads are nothing but lights, fans and all. Okay, and C type is preferred for inductive loads like cooler, washing machine, fridge, AC and all. D type is preferred for highly inductive loads. Highly inductive loads, the only difference is tripping mechanism. Okay, the tripping mechanism for the circuit breaker to get trip. Okay, now, so only remember one thing, that MCB should be preferred if your current rating in the LT side is from 0 ampere to 63 amps. Next is MCCB, miniature molded case circuit breaker. Now this MCCB has to be is available in the market in DP and TPN. TP and TPN, triple pole or triple pole neutral. MCB is available in the market in both TP and TPN. It is used for current rating in the LT side from 63 amps to 1000 amps. It's not 800 amps, up to 1000 amps. Nowadays MCCBs are preferred up to 1000 amps also, it is available. So MCCB are preferred from 63 ampere to 1000 amps, and these are mostly used in where SMDB, sub-main distribution board panels, or main distribution board panels, based upon the current rating. So these are mostly used in MDBs or SMDBs. Next is ACB, air circuit breaker. Air circuit breaker is preferred for current rating in the LT side. Air circuit breaker is preferred for current rating in the LT side from 1000 amps and above, we go with the ACB. Up to 63 amps in the LT side MCB, 63 amps to 800 amps or 1000 amps MCCB, and more than 1000 amps in the LT side, we go with the ACB, air circuit breaker. So this type of circuit breaker is used for current rating in the LT side from 1000 amps and above. This type of circuit breaker is available in TP and triple pole neutral only. No TP again, triple pole neutral, and mostly used in the main distribution board panels. And it also have a auxiliary protection circuit. Means you can control the on and off operation of this ACB from different location, because inside that ACB you'll have a shunt coil, you have a small coil where you can operate the operation of on and off of the circuit breaker from different locations. Okay, next is now. Any question up to here?
तो रेसिडेंशियल में इंडक्टिव और रेजिस्टिव लोड दोनों रहते हैं, तो फिर कौन सा डी टाइप कर्व यूज करना है, सी
C
टाइप?
type, C type, C type.
और
C type can be work for both type ना.
और आरसीसी भी यूज करना चाहिए क्या फिर ज्यादा, या ईएलसी भी कर सकते हैं रेसिडेंशियल में?
ELC भी नहीं करना है, RCC भी करना है. RCCB is only preferred. Okay, any more questions? Okay, now guys, do the current calculation for this 500 kVA transformer, for find this 500 kVA transformer at point A also and point B also. 500 is the kVA of the transformer. Tell me what is the current at point A and tell me what is the current at point B. Yes, I want the current at point A and point B.
It's 95 amps.
Where you got 95 amps?
A.
How it is 95 amps?
It's 95 amps.
695.
हाँ.
At point A or point B you're talking?
695.62.
Six 95.628 point B or point A?
The point B.
Point A. Point B, sir. Point B.
Okay, tell me for point A then.
वो नहीं पता सर कैसे गए.
Simple, the voltage is level kV na here.
Okay, okay.
Then already we have done lot of things. Again you're asking me a question.
$26, sir.
26.24.
Okay, how much? 26.24.
Yes, sir.
Okay, so now you got here the current is in 26.24. Here you got the current is in some 630. How much? 630?
99.
680 or something you told. How much?
95.
5.62.
Okay. Now tell me what is the circuit breaker has to be provided at point B? Which kind of circuit breaker has to be provided for point B?
Current transformer, CT.
ACB, sir. Is A, was it CB, sir?
ACBs.
A, ACB, sir.
ACB is preferred up more than 1000 amps, na?
Yes,
More
sir.
than 1000. That's
Current
sir.
is 6085, so it should be MCCB, na?
Yes, sir. MCCB.
Yes or no? Okay.
Yes, sir.
Because MCB is preferred up to 63 amps. 63 amps to 1000 amps MCCB. More than 1000 amps, we need to go with the ACB. Am I right or not?
Yes, sir.
Yes, sir.
Okay. Now tell me what is the kind of circuit breaker has to be preferred for point A at location A.
MCB.
Others? Yes, others. What is the kind of B? I told you MCCB of, suppose market availability is 800 amps, you will go with MCCB of 800 amps.
सर एसटी ब्रेकर आएगा उधर ऊपर
Up to 63 MCB.
Yes, but do you think incomer is MCB, outcomer is MCCB?
No.
Is it correct?
No, sir.
No, sir.
No, sir.
BCB,
What
sir.
we need to do?
BCB, sir. BCB. Vacuum
सर यहाँ
circuit.
फ्यूज लगेगा सर पतला वाला फ्यूज सर
Fuse.
यस सर फ्यूज
That is HT fuse. HT fuse तो लगेंगे. Okay.
Fuse
Now
तो
guys,
लगेगा।
see here. See here. Your current in the HT side is very much less. That is 26.24. So if you propose according to the LT side in the same way, HT side it's not going to work. Why? Because HT side the voltage is very much high and current is less. Okay. So if I put 26.24 amps, that is around 32 amps. Suppose 32 amp circuit breaker. Within a second, the circuit breaker become ash. Within a second, the circuit breaker become ash. Now you might tell, why sir 63 amps तक MCB तो withstand होगा? Yes. So MCB can withstand up to 63 amps, but MCB doesn't have arc quenching medium. What is arc quenching medium? I'll tell you. Example, take an example. There is one cable. The current is flowing like this. You had applied the voltage of 230 or 415 voltage. The current is flowing like this. Now the same cable I'll take and I'll cut into pieces like this. Will the current flow, guys?
No, sir.
There
No.
will no chance of current flow. Why? Because there's a lot of distance from here to here. Okay, there is no chance of current flowing. Now the same cable I cut into pieces, I apply level kV. Will the current flow? Yes,
No, sir.
it will flow. How it will create arc? It will create arc like this. It will create arc. Then the whatever the air particles which are there in the medium, that will get ionized. Then in very less current, but current will flow because it will create arc because of huge potential. Huge potential. Even though there is no contact with this one, there's a chance of current flow. The same way, take an example, circuit breaker. Now, how the circuit breaker work, guys? What is the concept? NONC. Am I right or not? It works on a concept of NONC. Okay. So normally, when you are opening the circuit breaker, it is like this. When you are closing the circuit breaker, the terminals will get in contact like this. It is contact, and open means this is normally closed. Where the circuit breaker is normally closed, and normally open means when you are operating the circuit breaker, it will become like this. It will become like this. Yes or no?
Yes, sir.
So when you are giving the level kV point of supply, when your circuit is closed, the current flow. But when you are opening the circuit, suppose circuit breaker you are off, you are on and off taking, then this, when your circuit breaker is on and off taking, when it is moving, this total space will become arc. Why? Because of huge potential, even though there is no contact between that, here
Yes,
it
sir.
become ash.
Yes, sir.
And it become arc. When it become arc, what happened? This MCB is a plastic. Then MCB doesn't have arc quenching medium. It will become ash.
सर यस
Yes, sir.
So LT set circuit breakers can't be used in the HT side because they are not defined for the higher voltage. Now what we need to do? HT set circuit breaker should have arc quenching medium. HT set circuit breaker should have a arc quenching medium, in which we have three kind of circuit breaker: oil circuit breaker, vacuum circuit breaker, and sulfur hexafluoride circuit breaker in the market. But oil circuit breaker I didn't show here. Why? Because oil circuit breaker mostly people are not using nowadays because of huge maintenance. There's a huge maintenance in the oil circuit breaker because of that reason. So oil circuit breaker means what? The terminals are placed inside the oil. The on and off terminals are placed inside the oil. So when you're operating the circuit breaker, there is no chance of arc because there is an oil which have a high dielectric strength which quench off the arc. But what is the drawback? For every 15 days or 20 days or 1 month, we need to do the replacement of the oil. When you're doing the replacement of the oil, the total power will be off for the building. So this is the major drawback in oil circuit breaker. And if it is designed, they had been used up to level kV point of supply. HT set circuit breaker never proposed according to the current. HT set circuit breaker has to be proposed based upon the voltage. So oil circuit breaker was designed to use up to level kV, but due to the drawback of heavy maintenance, people are not using that. Then people came with a concept called vacuum circuit breaker. Now what is this vacuum circuit breaker? Okay, vacuum circuit breaker means the terminals are placed inside the vacuum. Why? Because in order for the fire accident to occur, there should be one thing called oxygen. If oxygen content is 0, there is no chance of fire accident occurs. So that is the reason vacuum circuit breaker, where the terminals are placed inside the vacuum, because in a vacuum the oxygen is 0. So the terminals are placed inside the vacuum. As the oxygen content is less, there is no chance of arc occur. These are used for up to 33 kV, like level kV, 22 kV, 33 kV, we go with VCB only. More than 33 kV in the HT set, we go with SF6, sulfur hexafluoride circuit, because here the terminals are placed, the on and off terminals are placed in the gas balloon, sulfur gas balloon, so that whenever your on and off operation take place, that gas will release that will release the gas and it will quench off the arc. Okay, and it is used for designing the point of supply about 33 kV, like 66 and 132 kV, we go with the SF6. Am I clear? Hello.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, okay. Now, how the circuit breaker is denoted technically is, circuit breaker technical denotation is, how the circuit breaker is denoted in the AutoCAD, that it should be denoted like the symbols I already told you, or what are parameters should be represented on that: ampere rating of the circuit breaker and the type of the circuit breaker by fault current and tripping time. Circuit breaker technical parameter denotation is fault current or short circuit current. What is that? I told you already, we done the calculation. It is defined as the fault current which flow upon any fault occur, that is line to line or line, etc. It is always written in coulombs, which already we calculated. Okay, circuit breaker technical parameter denotation is ampere rating of the circuit breaker, which we need to calculate, and the type of the circuit breaker divided by fault current and tripping time. So fault current means it is defined as a current which flow upon any fault occurs, which already calculated just now for all the feeders in coulombs. Now what is tripping time? Tripping time means it is defined as a saturation time for the circuit breaker to get trip off if any fault occurs. Agar fault ho raha hai, if the fault occurs and if the fault current is increasing beyond the fault current which you got it up, then it should get trip off. The circuit breaker should get, at what time it should get trip off. So we are going to do that calculation now. That is called tripping time. And HT said always the tripping time is 3 seconds, but LT said the tripping time lies between 0.01 second to 1 second. HT said may by default, manufacturer by default it's 3 seconds only, but LT said it lies between 0.01 second to 1 second. So we need to calculate the saturation time in that 0.01 to 1 second. Am I clear?
Yes, sir.
Yes, sir.
Okay. Now, how we calculate the ampere rating of the circuit breaker? Let us take an example. There's an example. I have a 2.5 HP motor. There's a 2.5 HP motor. I calculated the current. I got the current as in 10 amps. A 2.5 HP motor. I calculated the current. I got 10 amps. So if we put exactly the same ampere rating, because in the market you have 10 amps is also there. In the market you have 10 amps is also there. If I put exactly same 10 amps of the circuit breaker, then what happens? The moment when you switch on the circuit breaker, it trips. Example, I have a 2.5 HP motor. When I calculated the current, I got 10 amps. Now, if I put exactly the same 10 ampere rating circuit breaker, the moment when you switch on the circuit breaker, it trips. Why? Because every equipment will always run under full load condition. Every equipment will always run under full load condition. If you got the same ampere rating and if you put the same ampere rating availability, then it's not going to work. It trips the moment when you switch on. There is no fault, but it trips when the moment when you switch on. So, To avoid such kind of things, what we need to do, we need to always, we never put exactly the same ampere rating of the circuit breaker which you got up. Okay, we need to put some 25% extra than the rated current. So that is the reason circuit breaker size is equal to full load current into 1.25. For all the LT set, the formula for the circuit breaker sizing is full load current into 1.25, because we are taking 25% extra than the rated full load current. So that is CB size equal to full load current into 1.25. But for HT set, it's not B. For HT set, there's a separate standardizer, I'll tell you. But for all the LT set, the circuit breaker size equal to what is the full load current into 1.25. And fault current, which we calculated just now. Now we need to calculate the tripping time also. Am I clear? Any questions here?
सर अगर वो 10 एम्प्स का एमसीबी लग रहा है, अगर 16 एम्प्स का लगाएंगे तो वो एकदम ज्यादा हो जाएगा ना सर, तो फिर वो ट्रिप काम नहीं करेगा.
कहीं को काम नहीं करे. सेफ्टी बोले तो in terms of safety it will not give that much protection, but if that equipment is more costlier and if you want to give a more protection, we get TOLR, thermal overload relay लगा लो, then you will get exactly the ampere rating कितना चाहिए उतना सेट कर सकते हैं. Okay, but you see, if that equipment is very much costly, and if you want to give a much more protection to that equipment, then you need to give a TOLR, thermal overload relay. You'll get it up. In that TOLR, you can adjust whatever the current rating you want. To it in that TOLR, you'll get 12.1, 12.2, 12.3, 12.4, 12.5. Likewise, also you'll get. That is the reason motors mostly prefer TOLR. They'll put TOLR for the motor, because motors are costliest equipment which takes high current at the time of starting, and which usually take, if any bearing got damaged, they'll take it up. Okay, but normal loads and all, they'll not take that much current than that.
पर वो
Okay.
ब्रेक नहीं करेगा ना सर सर्किट को, जैसे एमसीबी का काम है ब्रेक करना, तो वो 16 एम्प्स पे चलेगा.
हाँ, अगर वही बोल रहा हूँ ना, 16 एम्प्स लगा रहे, तो इसका मतलब क्या है, जब अगर आप मेरा करंट 16 एम्प से ज्यादा होगा तो ही ट्रिप मारेगा.
एग्जैक्टली, बट
राइट.
करंट अपना 10 एम्प्स ही है और अपन 16 एम्प की एमसीबी लगाएंगे तो फिर.
बट वी डोंट हैव दिस लेवल एम्प्स 12 एम्प्स ना, तो उसी के लिए और आपको सेफ्टी देना है तो यू नीड टू पुट अ फ्यूजेस. Okay, you'll get a fuses. Like example, you see in your home grinder. Okay, in your grinder below bottom, you'll have a fuse.
Yes.
Apart from the normal circuit. So because exact you'll get it up. Okay. So because manufacturer doesn't have the circuit breaker for 12 amps to MCB, 13 amps MCB, it's not there. So you need to put a fuses. Okay, like you'll put 14 amps or 12 amps fuses. Then if it is more than 12 amps, it will get rip off. Okay. Apart from the circuit breaker which is there in the DB, they'll put individual equipment also fuse. That is the reason when you see in our household equipments, for every individual equipments, they'll put a fuses also.
Yes sir.
सर एमसीबी ओनली के
Yeah.
ब्रेकर के लिए काम करता है क्या, ना दूसरा कोई कुछ काम करता है?
ब्रेकर
Hello?
में दो चीज के लिए, एक तो लोड करंट ज्यादा हो गया तो ट्रिप मारेगा, और शॉर्ट सर्किट हो गया, शॉर्ट सर्किट करंट उससे ज्यादा होगा तो भी ट्रिप मारेगा. ओके, बट लीकेज करंट नहीं देगा वो.
ओनली प्रोटेक्शन के लिए
आरसीसीबी.
या अब उसके नहीं, लीकेज करंट तो उसके लिए इनकमर में अपन आरसीसीबी लगा दिए ना. कहीं पर भी लीकेज होगा तो आरसीबी ट्रिप मारेगा. तो कभी भी एमसीबी विल गिव ओनली टू प्रोटेक्शन. वन इज if the load current is more than the set current, it will get trip off, and if the fault occurs and if the fault current increases beyond the whatever the fault current which you provided, it will get trip off. Am I clear?
Okay sir.
ओके
Yeah. So shall we stop for the day? Tomorrow we'll continue.
सर क्लास नोट नहीं मिल रहा है सर.
अभी बेस
Sir, note-
सर
okay, I'll send you now up to the
Sir.
date.
सिटी और पीटी का कल बोलोगे क्या?
सीटी और
अभी-
सीटी का तो मैंने ऑलरेडी वीडियो में दिया है ना, ट्रांसफॉर्मर का वीडियोस में मैंने भेजा ना आपको.
ओके ओके.
सर ट्रांसफॉर्मर वीडियो में सर वहाँ पे सर ट्रांसफॉर्मर का टेस्टिंग नहीं है सर.
यहाँ पर वी आर नॉट इनटू दैट थिंग्स, वी आर ओनली इनटू डिजाइन ना.
ओके.
यहाँ पर ओनली अपन डिजाइन सीख रहे. वी आर नॉट टेस्टिंग, वी आर नॉट इनटू मेंटेनेंस, वी आर नॉट इनटू डिजाइन, वी आर ओनली इनटू डिजाइन ऑफ द टोटल पावर सोर्स इक्विपमेंट्स फॉर अ बिल्डिंग.
सर पीटी के बर्डन का भी आप बोलोगे ना, कैसे कैलकुलेट करना?
ठीक है, आई विल टेल यू दैट. ओके
ओके ओके.
ठीक है. ओके ओके गाइस, सी यू टुमारो.
ओके सर, गुड नाइट.
ओके, गुड नाइट, थैंक यू.
Okay, sir. Okay.